Okay, so today we are going to discuss refraction through prism. We have already studied refraction through glass lab and prism in class 10. There we have studied that how an incident ray of light falls on glass surface of glass lab or prism, and how after going through refraction through these objects it emerges out. But the emergent ray emerges out in different ways from these two different objects. Okay, so for instance, if I consider, just wait, for instance, if I consider that this is my glass lab, right, and this is any normal, this is the normal for this particular surface, okay, and if I consider normal for this particular surface, now if I consider any ray coming in this direction, incident ray, right, now we know that this medium is glass. Okay, and again this medium is air, and again air. Right. So this ray is actually moving from air to glass. That means from rarer to denser medium. So as we know, and then when happens such, that it is moving always towards normal. So this is what it does. It moves towards the normal while traveling through the glass slab. Now again, when he comes out from glass slab to air, so he's moving, from denser to rarer medium. So in this case, we know what happens. And he moves away from the normal, and this is what it does. It's moving away from the normal. Okay, so this is what our ray diagram looks like. But there is interesting phenomena. Interesting phenomena here is that, for example, if you consider this ray, and if I don't place this glass slab in between, then he must have followed this path. Yes, but instead of following this path, okay, he moves through this path as there is change in medium, and then again he moves through this path, again there is change in medium. Okay, so what we have seen is that the incident ray, okay, this is my incident ray, right, this is my incident ray, this is my refracted ray, okay, the ray inside the glass, and this is my emergent ray. You see certain change in path is happening because of the change in medium, right? So now we see that the incident ray and the emergent ray, they are not in the same line. Yes, we see a certain lateral displacement in between them. Yes, so this is what happens in a glass slab. If you allow any ray of light to pass through the glass slab, it passes through it and then comes out through the which is termed as emergent ray, and we see a lateral displacement there in between incident ray and the normal emergent ray. But when we discuss for glass prism, okay, there is also, we see incident ray, going inside the prism. That ray is again refracted, and then again that refracted ray comes out through that prism, from the prism, okay, which is termed as emergent ray. But we see certain angle there. Okay, there is an angle between emergent ray and the incident ray. That angle we have termed it as angle of deviation. We will see in the later part of the session, and we are going to see that how that angle of deviation is not constant. It gets varied. once you change your incident angle, okay, the angle of deviation also gets varied. Now this is what we are going to study here. We are also going to find an equation which will be related to angle of deviation, and we can find the refractive index value, right? Okay, so these are certain parts. Yes. So these are certain parts of the prism. Now you see, just a second. Yeah. Now this is the refracting surface of the prism. You have another refracting surface at the back side, and this particular line, which is termed as refracting edge, joins these two opposite facing refracting surface. Here we have angle of prism, and this is a very important parameter. You will see in the later case that while deriving the refractive index, you will be actually requiring this angle of prism value, and there are numericals related to this angle of prism value. Okay, so this angle is nothing but whatever we consider for equilateral triangle, the angle between those two edges. So in general, this angle of prism is considered to be 60 degree. So this is what you have to remember. That angle of prism. You can just pause the video and you can just note it down. That angle of prism. I haven't mentioned it here, but you can note it down. That angle of prism for any triangular prism is always 60 degree. So these are just few key points. You can make a note of it. Okay. Yes. So this is the ray diagram. Okay. Here also you can pause the video and you can draw the ray diagram. I'll make you understand that what is happening here. So at the beginning, what we have seen for glass lab, this is quite same. This is my incident ray. Here I have represented incident ray as PE. Okay. Now this NN dash, this is the normal for the phase AB. Okay. So when this incident ray is getting incidented at this point E, it gets refracted since it's moving from, again air. So this part we have air. Okay. Okay, so this part is air. This part is glass. Okay. And then again we have air here. All right. So since he's moving from again rarer to denser, so he's refracting towards normal. This EF is my refracted ray. Now in case if we don't place this prism ABC where we have placed right now, this ray PE, it must have moved in this direction. It should have moved in this direction. That means in the direction of E and H. But since you have placed this prism ABC, so he has refracted and now he is moving in this path EF. Now you see that it has deviated through this angle. You can see that. Let me just yes. You can see certain angle there. Yes, so this is my first angle of deviation. Now again, yes. Now again, if you see this ray, now he is moving from glass to air. Now again, mm dash, this is the normal to this surface AC. Now since this ray EF is moving from glass to air, from denser to rarer, so he is moving away from the normal. Okay, so he's moving away from this normal mm dash. So there also we see certain angle of deviation. Yes, because like for example, if you see this angle, this is another angle of deviation. because it must have moved, it should have moved in this direction, in this straight line. Yes, but since the medium has changed, so he has moved, in the path to fs. So we have two angle of deviations, and when we total them, so we get this entire angle of deviation. Okay, now this angle, total angle of deviation, we have turned it as d, so you can see that d. Okay, so d is nothing but my total angle of deviation. Now d is the angle of deviation between incident ray, you see this incident ray EE following the path of EH, and RS is my emergent ray. So this D is the angular deviation between incident ray and emergent ray. So this is quite different from what we have studied or seen in glass lab. In glass lab, we didn't saw any kind of angle between incident ray and emergent ray. Instead, we have seen a lateral displacement between the incident and emergent. In Prism, we see that the certain angle is there, D, between incident and emergent ray. And as I was saying, that this D is not a constant value. It has different values. It depends on this angle of incidence, I. So the more you change your incident angle, the more change the value of angle of deviation you will see. Now, how it changes, we will see in the little slides. Okay. You can just note down all this parts: incident ray, refracted ray, what is my angle of prism. Here you see that angle of prism is this, which is always 60 degree. Angle of emergence, this is my angle of emergence. Okay, right. So this is another ray diagram. Okay. Okay. So this is another ray diagram. Now you can just this ray diagram is very important because it has more clear ideas. You see there's slight mistake here. Okay, you see this angle R1 minus R2. Please correct it. It should be I1 minus R1. Okay, instead of R1 minus R2, it should be I1 minus R1. Again, this angle I1 minus I2, it should be I2 minus R2. Okay, I'm again saying this angle R1 minus R2, it should be I1 minus R1, and this angle I1 minus I2, it should be I2 minus R2. Okay, all right. Now what are these angles? These angles are nothing but, suppose, for example, I'll make you understand this. Suppose this is any surface, okay, any interface which divides the medium, and suppose that this is any normal, okay, normal which perpendicular to this surface. Now let us consider a ray which is coming in this direction. Okay, 1 second. Okay, so let us consider a ray which is coming in this direction. All right. Now, since if I consider that this is rarer, and if I consider that this is denser, all right. So this ray is going to move towards normal. So this is what it does. He's moving towards normal. Okay. So this angle, this is my angle of incidence I. Yes. And this angle, this is my angle of refraction R. Yes. But if I didn't change my medium, then this incident ray, it must have moved in this direction. Yes. Then what will be this angle? So it is clearly seen that this is nothing but I minus R. Yes, because this entire angle is going to be I, vertically opposite angle, and here we have R, a small part of it. So this is why this remaining angle is nothing but I minus R. So this is what is happening here at this point, not only at this point, but also at this point. If you say this point, this is my incident ray EF, and this is the normal N1N. He is moving from air to glass, so that is why he is reflected towards the normal. So this angle is R1. Okay, so what will be the remaining angle? I1 minus R1. Again, this ray is moving in this direction. He is getting incidented to this interface PR. So he is refracted away from the normal. So this particular angle is R2, angle of refraction. Now in this case, it is angle of incidence. Yes. This is angle of incidence, which is written as R2, and this is my angle of refraction, I2. Now in this case, I2 is called angle of emergence because it is related to my emergent ray. So that is why angle of emergence. This particular angle, the remaining angle is nothing but I1 minus R2. Okay. So you pause the video and you can just clearly understand what is this ray diagram. If you can understand this ray diagram, then it becomes easier for you to understand the entire derivation. And again, you will see another angle del. As I've already mentioned in the earlier slide, that del is nothing but the angle between incident ray and emergent ray GH. So you have incident ray EF, you have refracted ray FG, and you have emergent ray GH. So this is the angle between EF and GH. Okay. Now, okay. So these are just whatever I've explained. I have made a note of it. You can just note down, pausing the video. Now we start with the derivation. What we will do at the beginning, we will consider this quadrilateral E, F, and G. This quadrilateral, we need that. Now if we take angle sum property for this quadrilateral, so we add all the four angles. That is FPG, PGN, FPN, PFN, then FNG. If we take a sum angle of all the angles, that we know that it is nothing but 360 degree. Now look at the angle PFN and PGN. Now this angle PFN and PGN, they are all 90 degree. Why? Because these angles are made with this interface and with this normal. Okay, so that is why PFN and PGN, these are 90 degree. For example, if this is the normal, sorry, if this is the face interface which is dividing the medium, in this case PQ is my interface. It is the separating medium, the separating boundary. And if I consider a normal this direction, so obviously this angle between them is what, 90 degrees. That is why we have considered that PF and PGN is 90 degree. Okay. So when we put all those 90 degrees, so we get a final equation that angle of prism A, where FEG is nothing but angle of prism. That is why we have written it as A, FEG, okay? And FNG, the sum of these two is nothing but 180 degree. Now again, if we take triangle FNG, okay, FNG. So if we take these two triangles, So again, if we use angle sum property, so again R1 is nothing but, I have not written it, but I think you should be able to understand. R1 is nothing but NFG. Okay, R1 is nothing but NFG, and R2 is nothing but NGF. Okay, so these two angle plus FNG, which I have written it as theta. Now if you take the angle sum of this, so it comes out to be again 180 degree. Okay, now if you compare equation 1 and equation 2, all right, if you compare equation 1 and equation 2, so you see that A and R1 and R2, okay, because it's same, right? A plus F and G is 180 degree, and R1 plus R2 plus F and G is equals to 180 degree. So if you compare these two equations, so what we can conclude is that capital A is equals to R1 and R2. Yes. So this is what we are going to take at the finding. Okay, so from 1 and 2 we get that capital A is equals to R1 plus R2. So this is a very important equation. Now this angle of prism is related to angle of refraction R1 and angle of incidence R2. Okay, angle of incidence for this surface PR. So, because we'll be using this equation in the later part of slides. Okay, now again, if you consider triangle QFG, now Q, you can just make this point that Q is nothing on this point. Okay, I have not mentioned it here. You just really mention that Q is this point. Okay, where I have pointed my spotlight. Okay, that is my Q. Okay, so this Q in triangle QFG, this triangle if you consider, then del is nothing but my angle of deviation, which is also my exterior angle. Now we know that angle sum property, sum of two interior angle is equals to the exterior angle. So this is what we are going to see. QFG and QGF. QFG and QGF. These are my two remote interior angles, and del is my exterior angle. So that is why we have written this equation. Now we have replaced the values of QFG. So I have clearly mentioned here I1 minus R1, and again I2 minus R2. At the beginning, I have already mentioned that we need to make these two corrections. So okay, replacing these values, I1 minus R1 plus I2 minus R2, this is equals to del. So if you simplify this, so you will get that I1 plus I2 is equals to A plus del. Simplify. So these two equations are very important. Okay. These are the relation between angle of prism, angle of deviation, incident angle, emergent angle, incident angle of refraction, and then again angle of incidence for the second surface. Yeah. Okay. So thus, when a ray passes through the prism, the angle sum, the sum of the angle of prism and angle of deviation is equal to the sum of the angle of incidence and angle of emergence. So this is a very important derivation. This has been asked a number of times in board exams. Okay.